Alright, so our goal in this chapter is going to be to come up with some sort of mathematical model to explain this randomness. We don't want to have to do a full simulation on every single problem that we come up with. There's got to be an easier way. Now, we've done all kinds of mathematical models in here. We've come up with a mathematical model to fit a line. We've come up with a mathematical model to fit a curve. Okay? We've done mathematical models for normal distributions and figuring out the probability in each one of those. Now we'd like to come up with some sort of mathematical formulas, if you will, for randomness. Flipping a coin. It could be as easy as flipping a coin. We all kind of realize probably getting heads is 1/2. But it could also go as hard as to find a match of a birthday in here. How in the world do we find out what the probability of that is in the long run? Okay, so we're going to start building our case for these things called these mathematical models, which will help us come up with these probabilities. Before we can do that, we got to get some models tomorrow. We have to learn about this very important subject of the sample space. Sample space is defined as the list of all possible outcomes given a question that's being asked. So in your warm-up here, you had 5 students, and you had to pick a president and a vice president. How many different outcomes are there in this particular problem? 60? 16. That's actually, there was actually 20. Okay? Now we're going to show how to do that a couple of different ways, but there was actually 20 different ways that you could have had a president and a vice president from that particular problem. That number 20 is a number we're going to use in calculating, the probability of flipping heads, and that number we'll use to try to figure out if there's a birthday match in here. You've done sample space before. You've already done it a lot of times. What we do in our distribution charts, over here we list every possible outcome. Take a look at the number 2 that we did last night. Based on the question that was asked, it was about how much money would you win? That's your sample space. Those are the only possible answers that there were given the problem that was asked yesterday. So you've been doing this. Okay, this is an example of what sample space is. All right, so let's go through these. If I flip a coin, what's my sample space if I flip a coin? What are all the possible outcomes we can get? Just heads and tails. Right? There's only 2 of them in this case. How about flipping 2 coins? Or if you want to think of it, flipping 1 coin twice. What do we got? Heads, heads. Heads, tails. Tails, tails. And tails, heads. Had a good question, 3rd period. They said, well, why are you counting this twice? Why not just once? Well, again, it depends on the question that's being asked. In this particular problem, I said, what are all the things that can happen if you flip 2 coins? Okay? What if I'd have asked the question instead, what are all the number of heads I could get? Well, in that case, I could get 2 heads, but in this case, they would just count as 1. Each one of those was 1 head or 0, so it'd be 0, 1, or 2. So again, it depends on the question that you're asking that helps determine our sample space. How about rolling a die? We talked about this one before. What are all the elements in our sample space here? 1, 2, 3, 4, 5, and 6. That's all that can happen based on the question that's being asked. How about rolling 2 die? Now this is one of your homework problems tonight. How many are there going to be? You're actually going to list them all tonight. How many different ways, there's actually 36 of them. 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2. So there's actually 36 of them, and you have a problem tonight that's going to ask you to write those down and do something with them. But rolling 2 dice, the same exact thing, but I'm asking a different question. What are the elements of the sample space going to be if I roll 2 dice and I want to add them up? What are all the possible answers that could come out here? Yeah, 2 is the lowest run, right? If you had a 1 and a 1, that would be 2. And this goes up to what? Yeah, all the way up to 12. Those are all the elements of the sample space. So if I was doing some distribution chart and I was adding up 2 die, this would go 2 through 12. Those are the only possibilities that there are. Now a subset is just a particular, an event is just a subset of a particular sample space. In other words, hey, I'm going to roll 2 dice. What are the different ways I could have 7 or more as the sum? So what would be in the subset of this then? 7, 8, 9, all the way to 12. Okay, so an event is just a subset of a particular large sample space. Okay, got a couple of helpers here for you to figure out what the sample space is. You said 16, so something went haywire a little bit. So you can do these to try to see a picture of it first. So let's go ahead and draw a tree diagram of this particular problem. Now, a tree diagram, quite often you'll see them going top down. We're going to draw a tree here. Sometimes you see it left to right. We're going to be using a tree diagram a lot in later sections, so I want you to learn this technique. Right now we're just using a tree to find the subset. So here's the thing about this. In this case, there were 2 different things that I was trying to find offices for, and I had 5 different people in each. So the way this particular tree diagram would work is I would start here, and now I'm going to pick the president. So that's the first level. I got 2 of these things, so I'm going to have 2 levels. So how many options do I have here in picking the president? 5. And they could be A, B, C, D, and E. Now, for each one of these, I now have to find a VP. So now, what this means is, okay, A is our president. So now how many options do we have, and what are they for the VP? Now I have just 4, and they could be B, C, D, and E. And now I'm done. I've got my vice president and president, so I can write what those are. This is AB, this is AC, this is AD, and this is AE. All right, let's complete our tree. Now right here, B is president, so how many options do I have? And what are they? A, C, D, and E. So I've got BA, BC, BD, and DE. Continuing to go here. I've got 4 coming off of here. I've got A, B, D, and E. I've got CA, CB, CD, and CE. Here I've got A, B, C, and E. I've got DA, DB, DC, DE. And finally, the last one, I've got A, B, C, and D. I've got EA, ED, EC, and ED. Tonight you have a couple problems where you're going to be drawing tree diagrams. That's what I want it to look like. But now, look at how many answers I have along the bottom. There's your 20. Okay. So if you're not sure you've got them all, I think probably a lot of you just did AB, AC, AD and went along. But if you're not sure if you got them all, a tree diagram is a nice way to see them all. Now, obviously, if I've got 40 people in class and I'm trying to fill president, vice president, treasurer, am I going to draw a tree diagram? No, I don't have enough pencils in the world. So this is good if you have a kind of a low number and you want to see what's going on. Tree diagram's a nice option. If I just want to know how many options I have, using this thing called the multiplication rule is a nice way to go. Okay, here's what the multiplication rule says. Look, if I'm going to do one thing and I have so many options, and then I'm going to do another thing and I have so many options, if I want to know the total that are down here, you can just multiply them together. Okay? Now, when you use the multiplication rule, okay, I want you to do it in these 3 steps. If you don't, you'll get it backwards. The first step I want you to do is just to draw blank lines. How many blank lines you draw is how many tasks you have to do, how many things you have to do. Like if you're going to dinner, and you order dinner, you had appetizers and entrees and desserts. Well, there's 3 things that you've got to do, so you would draw 3 dashes. In this particular problem, how many things do we have to do? 2. Okay? So the first step here is just to draw 2 dashes. Now you go to the first one, and you ask yourself a question. How many options do I have for this first one? This is president and vice president. So how many options do I have here? I got 5 people to choose from, right? times, now go to the second one. The idea is once I've picked my president, how many options do I have now? 4. And you can multiply these together, so there were 20 different ways. Alright, I want you to use this technique, and here's the question. When you guys do your multiple choice, usually there's about 8 of them, right? 8 questions. And each one of those questions, what, A through E, like 5 options? I want you to use the multiplication rule and answer me this question. How many different tests could be handed in? I guess one of them could be A. Another one could be A. How many different tests, total tests, could there possibly be? Use the multiplication rule. So the first thing I want you to do is draw your dashes. Then go to each dash and write in how many options you have there. And then go calculate it. Use your calculator and go figure out what that is. Got to figure out how many dashes would there be for this particular problem. All right, tricky question now. How many dashes did you make? You got kind of a couple options here, although I've heard way different answers all day long. How many dashes did you make? Yeah, actually there's 8. Aren't there 8 questions to do? Okay, so I agree, 8 dashes. You go to the first one, which would be the first question. How many options do you have here? 5. A through E, right? Now, for the second one, how many options do you have here when you're taking the test? You still have 5, right? For all of them. So this actually turns into 5 to the 8th power. Now, please do this, because when you do it in your head, a lot of times that turns into 8 to the 5th power. Okay, very easily, which obviously would be different. What is that, about 390,000-ish? Did you guess that? Almost 400,000 different ways for you to do the multiple choice part of that test? It's pretty big in a hurry. There's that many elements of the sample space. All right, we've done a couple of problems here, and they illustrate these 2 different words. We've already worked with this a little bit before, with replacement and without replacement. Remember when we're dealing cards, and they say pick a card, and what are the chances of it being read? Now if I put that card back in the deck, and I have you pick another one, that's an example of with replacement, and aren't the chances going to be exactly the same of you getting a red one in that situation? Okay, it's independent. What happened before didn't affect what happens next. But if I let you keep that card, so that's without replacing it, doesn't the probability change for the next one? And that's an example of dependent events. So in these 2 examples that I did here, this one when we were picking a president and a vice president, okay, after the first one, did it change for the second one? Absolutely, because we didn't replace. Okay, that's an example of without replacement. Once I had my president, he couldn't be both, right? That person was gone. Okay. This next one here, now when you go to your next multiple choice question, does it matter what you answered before? Not at all. Okay, so that's an example of without replacement. This is with replacement, I'm sorry. This is without replacement. Is that right? No.
Without is the...
Well, I got that backwards, don't I? With replacement is independent, that's correct.
No, with replacement is that.
With replacement's this one.
Yes.
Okay. In other words, I have A through E again. Okay. Without replacement, in other words, that person doesn't go back in, right? That person's out, then that's this one. So those are examples. Okay. Questions, comments? So tomorrow we're going to start learning the mathematical rules, but you have to understand sample space before we can do that. Good? Okay.